Hey there, welcome back to Road to Data Engineer. This is going to be episode 19. Um, Gym went pretty good today, and I just got done eating dinner and picking up the house a little bit. So I want to put in about an hour of study before going to bed because I don't want to stay up too late. It's already almost 11. So going to set a timer here for an hour, and we're just going to pick up where we left off in the Boot.Dev course for shells and terminals. And actually, I already used some of the stuff we've been learning in the course to go through my file directory, figure out what episode number we are on for the series, rename my last recording using bash, moving the file to my completed blogs folder, opening my YouTube template text file. So I already started using some of the stuff we've been learning just to like do some of the basic file manipulation I've been doing every time I upload an episode. So that was cool. I'm going to try to use what I'm learning as much as I can here at the house and at work so it really sinks in and I get all the commands and stuff under my fingers. And I found out actually too, because I was a little concerned that we're working on bash and not something that's Windows native. But PowerShell actually accepted most of the bash commands, or pretty much all of them that I tried, at least so far, even though command prompt is not. So maybe I should be able to apply a lot of the stuff what I'm learning directly to PowerShell, which is great. Okay, so let's get into the course. Compiled versus interpreted. Is this where we left off? Yep, using sudo. Yep, okay, here we go. A program is just a set of instructions that a computer can execute. We talked about executables in the last lesson. An executable is just a file that contains a program. The words program and executable are often used interchangeably. Broadly speaking, there are two types of programs, compiled and interpreted programs. Okay.
A program is just a bunch of instructions written in a way that a computer can carry out. And in a nutshell, there are two kinds of programs: compiled programs and interpreted programs. For our purposes, the real difference between the two is just that compiled programs do not rely on any other programs to be able to run. They're usually written in a language like C, Rust, or Go, but are then compiled down to binary, the raw language of your computer's hardware. Interpreted programs, on the other hand, do require other software in order to be executed. Python, Ruby, JavaScript, or shell scripts rely on an interpreter to read the code as they run. When you run a program on your machine that has no other dependencies, it can simply be ran by typing the name of the program into your shell. However, when you run an interpreted program, you need to tell your machine which interpreter it should use. For example, to run a compiled program called text editor, you might just type /text editor. To run an interpreted Python program, you might have to type python texteditor.py. And that's because the first one is a compiled binary. It's just ones and zeros that your machine knows how to execute. In the second example, texteditor.py is just a file of Python source code, so it needs access to the Python interpreter.
Okay, that all made sense. I probably learned that in school. Just for context, I have an associate's degree. I was going to school for computer science, but didn't ever finish. So I'm sure I learned that in school, but it's been a long time. So that was a really good refresher, and actually was something I was wondering about as I've been recently kind of watching some programming YouTube, and they'll talk about compiled versus interpreted occasionally. So that was a really good explanation. Okay, compiled programs. A compiled program is a program that has been converted from human-readable source code into machine code binary. Machine code is a set of instructions that a computer can execute directly. Your computer's CPU is hardware that's been designed to execute machine code. Programming languages, Go, C, Rust, are compiled languages that produce compiled programs. Machine code, computer consisting of machine language instructions, which are used to control a CPU. Although decimal computers were once common, the contemporary marketplace is dominated by binary computers. Interesting. Each instruction causes the CPU to perform a specific action, such as a load, store, jump, arithmetic. Interesting. Okay. An interpreted program is a program that is executed by another program. The program that executes the interpreted program is called an interpreter. The interpreter reads the source code of the interpreted program and executes it. Okay. Programming languages like Python, Ruby, JavaScript are interpreted languages. Your computer needs to have an interpreter installed to run programs written in those languages. Another example is the .sh shell script files we talked about. Those are interpreted by the shell program. Interesting. In your shell, run the following command, which sh. Which sh. User bin sh. The which command tells you the location of an installed command line program. In this case, we're asking for the location of the shell program. Okay. So to display the installation location of a command line program. In this example, the shell program. Which sh? User bin sh. Let's actually explore. Mine is located at bin.sh. Next, take a look at the contents of the file. Let's explore that directory a little bit. Let's go to the home directory. Yep. Let's go into bin. Whoa. Lots of stuff in bin. Which sh? Oh, okay. So we want to back out. CD user slash bin slash sh. Sh is probably a file or a program or something. Okay. Mine is located. Next, take a look at the contents of that file. Cat sh. Whoa. Now that's something right there. Keep in mind your sh program is a compiled executable, probably written in C. That's why when you try to view its contents with cat, you see what you see. Fair. A file with a .sh extension, on the other hand, is a shell script. It's a text file that contains commands that will be interpreted and ran by the shell program. They're both executable programs, but only one can be run without the help of another program. A bunch of gibberish raw bytes attempted to be interpreted as text. I think that's become a member for quiz access. Damn. Really? Damn, really? Is it? We might be Hmm. Hmm. I wonder, is how does that work? Like, hmm. If I go to like the Python course, for example, you're a guest. You can demo the first few chapters of each course for free. After that, you'll need to become a member to unlock the full access. Interesting. Okay. I mean, I want to take the quizzes to be honest. Let me think here. Let me look. Piping. Let me look through the courses real quick. So, programs and packages. Okay. So I know I want to do this one for sure. Or I want to finish this one. Python. For the Python one, I really want to. A lot of this stuff is stuff I've already done through W3 schools, but I probably want to like review function scope, testing, computing comparisons. Oh, wait, this might just be comparison operators, maybe not that one. Testing, debugging, computing, errors, challenges, and quiz. For Learn Git, some of this I will have learned in the YouTube tutorial we did. So set up repos, merge branching. A lot of this is going to be stuff that I've done already, but there's definitely some pieces like I want to go over merging again. I've been using Git at work, and obviously here at home some as well. But I feel like there's some areas that I need more grasp on for sure. So there's definitely some pieces here that I'd like to go over. Um, I could see myself going through this part too. I mean, I have learned a bit about classes for sure. I don't know about these, maybe. The Python stuff I'm kind of not sure about. Learn algorithms, I mean, this is something I'd like to do eventually, and learn data structures probably. Not super interested in JavaScript, but maybe HTTP. Again, not super interested in Go either. Um, very interested in the SQL section, in particular the CRUD, the structuring, normalization performance sections. Interested in the Docker. I mean, yeah, there's a lot here for sure. Mm. Uh, let's see. Code prime git. Uh, That's not bad. 35 for a month. Okay, cool. Yeah, so I think I am actually going to sign up. I've liked the website so far. I've been enjoying some of the Boot.Dev podcast too. And I think, at least so far, it seems like a pretty good product, honestly. So I'm going to sign up for this month and just, keep going through the course and whatnot. So I'm going to do that. Going to stop the recording, and I will be back shortly after signing up. Okay, and we're back. So I signed up for Boot.Dev. Been enjoying it so far. So just going to sign up for just this month, see how it goes. Go through some of the courses I'm interested in, but still work on the personal project too, and still use other resources. So we're just rolling with the punches, and we'll see. So, all right, let's answer our question. What is the output of catting the sh executable? A bunch of gibberish. Boom. Which can be executed without the help of an interpreter. A compiled language, not an interpreted language. A compiled executable like the sh program. A shell script like genNS. Okay, compiled executable for sure. Sorry, I was making sure my sound was on. Shebang. That works out of the box for files that are compiled executables. As we talked about earlier, you can run any executable file by typing its file path into your shell. For example, bin/genitis.sh. That works out of the box for files that are compiled executables. But what about scripts that need to be interpreted by another program? The computer needs to be told what program to use to interpret the file. Okay. A shebang is a special line at the top of a script that tells your shell which program to use to execute the file. The format of a shebang is number exclamation interpreter optional argument. Okay, let's write some of this down. Some of our notes around a little. Okay. That. Let's close a couple windows so I can navigate more quickly. Not sure why Alt F4 wasn't working there. Okay, so shebang is a special line at the top of a script that tells your shell which program to use to execute the file. A shebang at the top of your script. A script that tells your shell which program to use to interpret the file, i.e. format. The format of a shebang is the following. Number sign exclamation interpreter optional argument. For example, if your script is Python, is a Python script, and you want to use Python 3, your shebang might look like this: user/bin/python3. An example for a Python 3 script would be user/bin/python3 user/ bin slash Python 3. Right? Yeah. This tells the system to use Python 3 located at the user slash bin slash Python 3 to run the script. I wonder if that's there. I'm gonna guess not on my Linux one anyways. Let's see. Users or user bin. Okay. Hmm. Hmm. I wonder what my path has. Path. Or maybe like this. Or I think sometimes it's like this in Windows. PowerShell print path. Environment path. Environment. Oh, here we go. Windows System 32. And I'm assuming Python. Yeah, here we go. Users grant app data, local programs, Python 3 control script. Users grant app data. Local. Program. Programs. Python. Python 3.12. And what were they saying on Boot.Dev? It'll probably be Python 3. I'm assuming the Python 3 is in here. I'm assuming this is it, but I'm not sure. Use the cat or less command to view the contents of the private bin. Genitis file. Paste the shebang into the input field and submit your answer. I want to review the less command real quick. Touch command. Find. Oh, one page or line at a time. Less file name. Okay. Let's close PowerShell. Open Bash. Clear the contents. We're going to go to our home directory and we're going to cd world bank and cd private /bin ls tinnitus.sh. User bin environment bash. Okay. Boom. So that's a shebang. Okay, that's good to know. Bourne shell. For your main shell, REPL, as we talked about before, and REPL stands for something evaluate print loop. Replicate. What did REPL stand for? Read, evaluate, print loop. Read, evaluate, print loop. REPL. For your main shell, REPL, as we talked about before, if you're using Ubuntu on WSL, you're probably running a bash shell. If you're using Mac OS, you're running a ZHS shell. What is ZHS? Unix shell that can be used. Okay. Okay, so it's just, okay, that makes sense. If you're running a raw Linux installation, you already know what you're doing. That's so funny. To get hand wavy about it, I want to explain the difference between the three shells you're likely to encounter. SH, the Bourne shell. This is the original Unix shell and is POSIX compliant. It's very basic and doesn't have many quality of life features. Bash. The Born Again shell, Bash. This is the most popular shell in Linux. It builds on SH, but also has a lot of extra features. ZSH shell, the Z shell. Like Bash, it does what SH can do, but also has a lot of extra features. Both ZHS and Bash are SH compatible shells, meaning they can run .sh scripts. But they have extra features that generally make them more pleasant for use. For your purposes, the difference between them are not super significant. Everything we do in this course will work with both shells. Okay. Blank and blank are a superset of blank. They can do anything blank can do and more. ZH and Bash are a superset of SH. You know, anything SH can do and more. Nice. Bash and ZH both have configuration files that run automatically each time you start a new shell session. These files are used to set up your shell environment. I think I already messed with these when I changed the color of the way directories display in Ubuntu. They can be used to set up aliases, functions, environment variables. These files are located in your home directory and are hidden by default. The ls command has a flag that will show hidden files. So we're gonna move back to our home directory. LSA. I feel like they showed in my file explorer, though, to be honest. Where's my user? Home. Home. Yeah, but that's because I have hidden items on. Okay. I want to write that down. To list contents of the current directory, including hidden items. And what was that? That was ls-a directory name. of the directory. Directory name equals optional argument. Okay. If you're using bash, bash rc is probably the file you want to edit. If you're using zsh, is probably the file you want to edit or create if it doesn't exist. As part of your audit, you're trying to figure out what shell commands are run automatically when a user logs in on the machine. You need to confirm which shell configuration file is being used. Edit the file you believe to be the shell configuration file. Okay, so nano dot bash rc. Okay. Bash rc. C user dot, for example, startup files. If not running interactively, don't do anything. Don't put duplicate lines or lines starting with space in the history. C bash. Append the history file. Don't overwrite it. If set, make less more friendly. I mean, I think this is literally just the contents of the file. Enable color support. All kinds of stuff. Echo. Hello from the shell. Echo. Hello from the shell. You can use Control O to save the file. Confirm any prompts with enter, and then Control X to exit. Screen. Finally close your terminal and open a new one. You see the message, hello from the shell, you found the right file. Feel free to remove the line you added to the file so that you don't see that message every time you open the shell. That's sick, though. That's pretty sick. To be honest, I'm actually going to edit my file to say something kind of cringe, but fun. So I need to go ls. No. How do I show the hidden files again? ls.a. ls.a. And then I want to say nano.bash rc. And I want to scroll to the bottom of the file. Hello. And I'm going to edit it to say, hello, King. Hello, King. Let me watch you cook. I might be a zoomer, guys, to be honest. Control O. And Control exit. Hello, King. Let me watch you cook. That's sick. To edit a file. Let's take a note there. To edit, to open a file in the edit mode. Nano file name. Sample file dot text. Why might you restart your shell after changing a shell configuration file? Because the config file runs when you type ubu simpy please. No. Because it runs when you start a new shell. Yep. Environment variables. We talked about how you can create and use local variables in your shell, name, lane, echo. There's another type of variable called environment variables. They are available to all programs that you run in the shell. I've actually used these at work a bit for some shell scripting I've done at work. An environment variable is user-defined definable value that can affect the way running processes will behave on a computer. They're part of the environment in which a process runs. Interesting. They are available to all programs that you run in your shell. You can view all the environment variables that are currently set in your shell with the command env. Okay, let's do that. Whoa! That's a lot. But that makes sense. To view all currently set environment variables. env. The interesting part of is that programs and scripts you run in your shell can also use that variable. File called introduce.sh with the following contents. Hi, I'm name, then when we run it, change mod x introduce. Hi, I'm Wayne. To declare an environment variable. To declare an environment variable. Export variable name, variable value, export var name equals var value. Assignment. Take a look at the contents of the warn.sh script in the World Bank private bin. cd World Bank private bin directory. I want to do cat warn.sh. bin.sh. This script is used to present nice warning messages branded in World Bank style. Warn message from warn from name. If warn message, then warn message is not set exiting with error. If warn name, then warn name is not set exiting with error. Run the script and paste the output in the field and submit your answer. Export the required environment variables. It looks like it's supposed to print nicely, formatting warning messages with World Bank branding. So export variable name warn message equals the auditor is here. let's just see real quick. Or I need to say echo message. Okay, export warn from name equals your worst nightmare. Then I probably want to execute the script, I'm guessing. And how do I do that? I think I just call the script, right? Warn.sh. How do I execute the script again? To open a file, to view, to run shell scripts. I have to say warn.sh. There we go. I have to say which directory I'm running it from. Run the script and paste the output into the input field and submit your answer. World Bank warning, the auditor is here from your worst nightmare. You can temporarily set a variable for a single command instead of exporting. Exporting means the variable will persist until you close the shell. For example, warn message. This works too. Interesting. Okay. Was there anything else there? No. Path. Good old path. Yep. This is actually going to be really good. Path. This is one of the most important lessons in this entire course. Listen up, kids. There are environment variables that are sort of built into your shell. By built in, I just mean different programs and parts of your system know about them and use them. The path variable is one of them. Why do we care about path? If it were not for the path, you'd have to remember the file system path of every executable you wanted to run. Instead of just running ls, you'd have to run bin ls or whatever the location of the ls executable is on your system. That's not very convenient. The path variable is a list of directories that your shell will look into when you try to run a command. If you type ls, your shell will look in each directory listed in your path variable for an executable called ls. If it finds one, it will just run it. If it doesn't, it will give you an error like command not found. What is in the path variable? Gotta write this around. Write this down. To display path, echo path. I'm curious what's in the Ubuntu path. Bunch of stuff. Wait, did it? Is my Python stuff in here? Azure Data Studio, Git. Oh, Python. Okay, cool. I'm assuming it's still seeing Python, for example, because let's open a text file so we can read this. just kind of separating out the different file paths that are in my path variable here in a more easily readable way. You know, the only thing I'm kind of surprised by is that is that excuse me, is that it doesn't look like R is in my path. I downloaded R on my personal PC the other day. I'm surprised it's not in the path. You should see a giant list of directories separated by colons. Each of those directories is a place where your shell will look for executables. For example, with a path like this, your shell will look for executables in the following directories. Yep, assignment. As something of a security engineer yourself, you want to temporarily disable the path variables so that you can only run executables by using their full paths. You know, just so you don't accidentally run something you don't mean to. Reset your path variable to an empty string. Cringe, but okay. Oh, my time's up, so we're just gonna finish this last one here. And then call it a night. This will only affect the current shell session. If you open a new shell, it will have the default path variable. When you're done, try running some symbol commands like lspw echo, then answer the question. Okay, export. Path equals the cap. Ooh. Interesting. Okay, so some of the commands are part of the executable and some of them are like built into bash. Happens when you heard the command is not found. Boom. Okay. So that's cool. I'm excited to learn more about Path. Like I said, I've already used it some at work. And I have like a general understanding of what it is and what it does and how it works, but getting a more well-rounded understanding or even just some review is not bad. Okay, so thanks so much for anybody who watched. I hope you have a wonderful evening, and we'll pick up where I left off in the next episode. I'm guessing about 2 more episodes to go, maybe 3 to finish this course. So, anyways, have a good one.